Yeah. So as we know that this is common for both 17 scheme and 15 scheme, we already discussed with module number 1 and module number 2. So in module number 1 we have discussed with the development of telecommunications. In that we discussed about the structures, services, terminologies, regulations, standards, and various telecommunication transmissions, and we discussed power levels, how the conversions will be taken place of power levels, the derivation and some problems, and what is four wire circuits and some problems, echoes of four wire circuits, and we discussed about digital transmissions, how the data will be transmitted digitally, and differences between analog and digital transmissions, and we discussed about some of the digital transmissions like frequency division multiplexing, time division multiplexing, PDH, SDH. So this and all we discussed. In module 2 we have discussed with evolution of switching system and digital switching systems. So in this, as I already told many a times, that in module 2 it is of majorly of theory part, which discuss about the message switching, circuit switching, and distribution systems are the major things in the module number 2. And in the second part of module number 2, which is of full of theory and which is of text 2, which discuss about switching system hierarchy and how the switching system has been evolved, and the stored program control systems, building blocks of digital switching systems, like this. We are discussing about introduction, basic software architecture, call models, how the call models is going to take place, software linkages during a call. That means what are the software linkages required during a call process from source to destination, future flow diagrams of the calls establishment. Okay. So in the introduction part, let's we have the basic software architecture of typical digital switch. So we discuss mainly on how the software architecture is going to work and classify the various types of softwares involved in this, describes how the basic call models is going to take place, software linkages that are required during a call. Then we are going to discuss about some of the basic call features also in this module. Now, let us discuss first the operating system. We all know that operating system, in a short form, we call it as an OS. So we all familiar with our operating system because we are using computers, we are using laptops, PCs, mobiles. We know n number of OS. It may be Windows 10, Windows 7, Windows XP. If you come with the mobiles means Mac, iOS, or Android, some many versions, correct, Symbian, like that, right? So then what is actually an operating system? It is defined as a software that manages the resources of a computer system or controls and tasks other programs. In every digital switching system as an operating system as a part of its software architecture. So in this point we can say that an operating system, that is OS, is a part of software architecture. In theory, there are different types of operating systems which will be classified as serial batch system, multi-programming system, time-sharing system, and real-time systems. So real-time system is one of the well-known operating system which will be widely used, okay, which will works on real time. So best example for real-time operating systems or real-time suite like toll booths, automatic toll booths, how it going to open the doors. Okay, the operating system employed by digital systems or real-time operating system. That means, as I told, the operating system out of these all we are going to use is real-time operating system because it's going to work with real time, because we don't know when the busy hour will be there and what time the number of call may be increased or decreased. So we need real-time operating system. So we mainly concentrate on real-time operating system. So this is a block diagram of basic software architecture of typical digital switching system. So here in this we have a lines and trunks. This LM and TM is nothing but line module and trunk module. So we have, and we call it as level 1 control, and this is IC, which is nothing but interface controller, and this part we call it as, this whole part is called as level 1 control, which is having recovery operating system, that is called as level 1 kernel. So this is NCP. NCP is nothing but network control processor. Here what we are written here. So these are NCPs which will be at level 2 control. So we call it as recovery and operating systems level 2. And here at the third level we are having central processors which will be at level 3, which will be having all the things. So we have level 1, level 2 and level 3. In the diagram itself we can make a note that in level 1 we have line module, trunk modules. In level 2 we have network control processors. In level 3 we have central processors. So basic software architecture of typical digital switching system is convincible for digital switch to employ more than a OS. That means it will operate more than an operating system, because it has to perform various operations. So what is basically kernel? So kernel is nothing but a nucleus of an operating system which comprises those functions of OS that are most primitive to the environment. It is usually supports the following functions like process control, scheduling, how the process is going to be done, that will be controlled, and it will schedule each process, like main memory management, input output control of request of terminals and buffers, domain protection of main memory, it can be a read operation or write operations. Okay, next, database management. The database means, data means is nothing but an information. So databases that are employed in digital switching systems are usually relational and sometimes distributed. A record in a relational database is flat, that is a simple two-dimensional arrangement of data elements. A good example of relational database systems in a digital switching system is database systems that keeps cross-reference of all dictionary numbers that are assigned to the line equipment of the subscribers. Each network control processor has a replica of subscribers database for all other NCPs depending on the type of calls. A NCP may be required to route a calls through other network control processor. To accomplish this, the database information for all the network control processor need to be distributed and always kept synchronized. Okay. So as we all discussed in the previous slides about the three types of level, in this slide we discussed what actually do in each levels. So software architecture for level 1 control, it is called as the lowest level of control. This level is usually associated with lines, trunks and other level functions. So you need to remember this point, that is level 1 control is nothing but lines, trunks and other lower level functions. Most of the software at this level is a part of switching software. Okay, most of the software at this level is a part of switching software, and in level 2 it is an intermediate or the level 2 control are usually associated with network controls that may contain distributed database, customer data, service circuit routines. Obviously these functions are digital switching net architecture dependent. That means these are dependent on digital switching architecture. Many switching functions could be assigned at this level of controls. This is also important. Okay, let us continue with the software architecture for level 3 control. The highest level of control we call it as level 3. As we already discussed in the previous slide, that is level 1 control is the lowest level. Okay, so now uh, we have in the level 3, that is central processor of digital switching systems. So we know that what is the role of central processor. It's a main heart of the any computer or something. So here in digital switching system software architecture also, central processor is a main part. Normally these processors are mainframes, which are types of computers, so which provides high level functions. These high level functions includes the management of database, that is office data, high level subscriber data, then software patch levels, feature controls. Okay, subscriber data means it may be a name, the number, address, etc., or call details in and out like that. Okay, So next, digital switching system software classification. How the classification has been done. The basic software functionality of digital switching system can be divided into 5 basic elements. Other functions can be divided from these elements. That is switching software, maintenance software, office data, translation data, and feature software. So switching software, the most important layer of software of a digital switching system usually comprises of call processing software, that means how the call going to be processed, then switching fabric control software, network control software, peripheral control software. So these are the main important things on which the digital switching software is going to be dependent. Okay. Next, maintenance software. It controls the digital switching system software and related hardware such as line test, remote diagnosis, system recovery, and trunk test. The recovery software of the modern digital switching system is described among all the subsystems which controls the switching system. Next, features software. The features are considered to be an application of digital switch. It is nothing but an application. Some example of features packages are operator services, ISDN basic rates, etc. Okay. Office data. It defines the software parameters along with the hardware parameters. Software data of a digital switching system describes the extent of central office to generic program. Translation data. It is a data given by the subscriber. It is specific to each subscriber because each subscriber is an individual. The data of translation will be different for subscriber to subscriber. The telephone companies is going to provide the translation data, the database, and the entry for the translation data is a part of digital switching system. Next, as we already discussed the classification, we have 5 types of classification which is done pictorially, that is office data, which is short formed as OD, switch feature software SFS, translation data is nothing but TD, switching maintenance software, that is SMS, control and call processing software based on generic. And here we have two things, like this type of indication is called as direct interaction and this type of indication is called as software dependency. That means depending on the software, the flow of things or data will be taken place. Next, a basic call model will be having two things, that is the connection part and the disconnection part. And what are the parameters, what are the steps which are involved during a call establishment or the call connection is discussed here, and what are the steps which are involved during the disconnection of the call are discussed in this part, that is called as call disconnection. Fine. So in initial part of call connection, which the line has to be scanned, it has to be detect the half hook, then it has to test the line, then it has to translate it, connect the dial tone. So when you call to a person, we will receive a dial tone. Then after receiving the digit, it has to access the network map. Then it has to order the network connection. Then it has to hunt the network path. It has to establish a talking path, ringing called party. So if person 1 is calling to person 2, the person 2 should get a ringing tone. Again, it has to be detected whether it is answerable or busy. Then it has to be updated to the network map. Then start the timer of when start the establishment. When it comes to disconnection, again scan the line, detect the half hook, test the line, order the path to down and update the map, then stop the timer because the call has been disconnected. So now in depth we will discuss what are the consequences or the sequence which will be used for connection, that is call connection. The connect sequence consisting of software routine that scans the line and detect request for origination. Origination means the connection establishment. Once the line equipment informs the line scanner program that the line has gone half hook, this is a request for a dial tone. That means when you take the dialer and it start ringing or giving a dial tone, that means it's the connection is ready for receiving the input. It will pass the control to the test line program. The function of this program is to test the presence of the false ground, high voltage, line cross, and other conditions. After these tests, the dial tone is returned to the subscriber, signaling and the customer to start the dialing. Once the switches detect the start dialing, then the dial tone is removed and the digit received is attached to the line equipment. So the input which is given by the caller, that is dialer, that is the number, it will be attached to the line equipment. After receiving the correct number, the switching fabric will establish the talking path. After this ringing service circuit attached to called party, that means person 2. When the called party answer the call, automatic message accounting the bill, the call is started. That is timer is get started. The disconnection sequence. The lines are constantly scanned for disconnection from either of the end user. Once the half hook is detected from either of the party, then the switch network issues an order to terminate or turn down the call. That means disconnection of the call. Once the call is disconnected, the billing software timer is stopped. So now let us discuss about software linkages required during a typical call. So this is a block diagram which will deals about the software linkages which are required during a typical call, which is having a line modules, lines, and trunk modules and trunks. This is a switching fabric. So what we have discussed in the previous section, that is NCP, which is a network control processors, and this is a network status program. This is line control program. This is line service circuit program, and SC is nothing but a service circuit which we have discussed in module number 2 and module number 5. And this is a line trunk, and this is a disk unit, the backup for all the programs and data, feature programs, tape unit, automatic message accounting, translation of office data, call processing programs which are interconnected. Okay, these are lines, these are the trunks. Fine. So the software linkages for typical calls. What are the software linkages which are required for establishing a call, which we are going to discuss now? The line control program scans the status of the line via a line module and report the status to the network status program, which in turns work with the network control program. The line control program also work with line service circuit program. It is provided the dial tone, digit receiver, and ringing circuit. The network control program orders the network connection through the switching fabric when the subscriber goes half hook and complete the dial tone all the digits of the call. The call processing programs are responsible for the call processing function and interface with the features program translating the office data. The maintenance programs are responsible for the system recovery of the system diagnostic, backup, and other maintenance related functions. Okay. Next, the simplified flow diagram for call forwarding features, which in the short form it is called as CF. The feature activation, the feature operation, feature deactivation. How the feature will be activated, how it is going to be operated, how it is going to be deactivated. When the customer goes half hook, the dial of the activated code will be taken. It will be checked for the validity. If it pass, it will go to the next section. If it is fails, the activity will be rejected. When if it is passed, it will provide a second dial tone and the ring called number once and record of the number and activity of call forwarding. Okay. The feature operation. How the feature operation takes place? For incoming call, done line have activity. If it is yes, it's go further. If no, the proceed with a normal call processing. If it is yes, the ringing call line once before, then simulate all the number dial of the subscriber dialed. When it will how it will be deactivated, the customer goes half hook, the dial of the deactivation, it will check for the validity. If it fails, it will reject the deactivation. If it pass, it will go for deactivity call forwarding. Okay, that's how the call feature will be activated, operated, and deactivated. Next, simplified flow diagram for call forwarding features. The features is activated when the customer goes half hook and dials an activated code. The software checks for the correct validation code. If the code is wrong, the subscriber do not get a second dial tone. Okay, that means if the software check for the correct validity code, if the code is wrong, the customer will not get the second dial tone. If the code is correct, the subscriber will get a second dial tone. It is allowed to dial the call forwarding number. The number is rung once and the number is stored in the system memory for future use. The future operation. If the subscriber receives a call on the line that has a call forwarding feature activated, the system brings the called subscriber once then forwarding the call to the number previously stored. Okay, that means it will be havingly previously stored the number which already gone through, and the system rings will be taken place. The feature can be deactivated by dialing and deactivating the code. If it is correct, the call forwarding is deactivated. Otherwise, the request is ignored. Fine. Next. Okay. Fine. Let me stop at this point and let me send the further things. And still now we are discussed with module number 4, second part, which is a software part, okay, of a digital switching system, how the call will be done and all. In this session today, we are briefed about, let us summarize the things what and all we are discussed. So today in this we are discussed with module number 4, switching system softwares. So after that we have an introduction of basics software architecture. So we discussed about call models also, how the call models will be taken place, software linkages during the call, and how the feature flow diagrams it is going to take place. That also we discussed. So we discussed with operating system, what is an operating system, and types of operating system, and in digital switching system which type of operating system we are going to use, that is real-time operating system we have discussed. So and we discussed with basic software architecture, that is level 1, level 2, level 3, and what are the operations of each levels, which is lower level, which is higher level, and all we discussed. What is kernel we have discussed, and we discussed about database management. So we also discussed about the classification. There are 5 types of classification we discussed. Each one of them we discussed. And basic call models. It is having 2 parts, that is connection and disconnection. And step by step things we have discussed for both the parts. And we have discussed about software linkages which are required for establishing a typical call, how it will be done, how the features can be activated, how it will be operated, how it will be deactivated. That and all we have discussed. Okay, simplified flow diagrams also we have discussed. Okay, till number 3. So in introduction part, so here what we have discussed is pure chance traffic. So what is pure chance traffic means? Before going to pure chance traffic, what is a traffic in telecommunication? In telecommunication, okay, so traffic. So what is traffic in telecommunication? So we know in general what is traffic means. But in telecommunication, traffic means, that means the number of calls occur in a period of time. So if you consider a period of time, in that time, if how many number of call, if the more number of call occur, so we'll consider it as the traffic is high. Then what is pure chance traffic? Pure chance traffic means in any exchange on administration, we don't know when the call is going to increase or decrease. Okay, so it depends on the requirement of subscriber and it depends on the events. For example, during any festival season, so the number of calls or number of sending a messages will be more during New Year, during Christmas time, or any some festivals. Okay, so like that. So that is nothing but pure chance traffic. So here we are going to discuss with a diagram which indicates the x-axis as time and y-axis as call in progress. Here we have written 1 2 3 4 as the time for 24 hours, 12 hours morning, 12 hours afternoon. So here you can see the graph, the calls in progress. So it is taken in general, that is how the calls is going to get progress from morning 5 o'clock, and it will get to a peak at the time of 10 to 11 when all the peoples go to the office and they start their work, and it will start reducing during lunch time. Again after lunch again it will little bit increase. Again during evening when they going back to their home it will come down. Again, after reaching the house, they may start social calls, and again it may rise little bit and it may fall down at 12. This is the general scenario. So this particular dotted lines indicate that this is a busy hour. Okay, that is 10 to 11. That's what I indicated here. Traffic reaches its maximum at the middle of the morning and dips during the lunch hours. Again, it rises in the afternoon. It dips when the people return to the office. Again, it may rise when the people start making the social calls at the evening. This one. That's what I told, right? So now, some of the definitions let us discuss with respect to telecommunication traffic. That is busy hour. What is busy hour? I told hour means it's a 60 minutes, 16 to 60 seconds. The hour in which the maximum traffic occur in an exchange is known as busy hour. So busy hour means the hour in which the maximum traffic occur in an exchange is known as busy hour. The busy hour calling rate. So these are the definitions are very important. Definitely they I'll ask for 2 marks, that is explain the following or define the following, like busy hour, holding time, busy hour, calling rate, like that. Very important. Kindly practice. Remember. Again, I will repeat, the busy hour is an hour in which the maximum traffic occurs in an exchange is known as busy hour. Busy hour calling rate. The number of call originate per subscriber in the busy hour is known as busy hour calling rate. The number of calls originated per subscriber in the busy hour. Then what is holding time? The duration during which the equipment and circuit are held when a call is made is called as holding time. What is holding time? The duration. Duration in the sense a time period during which the equipment or a circuit, kindly remember, equipment or the circuit are held. Held means hold. When a call is made, it's called as holding time. So that is called holding time. This includes the period during which the call is being established and time taken to release the equipment at the end of the call. That means when the call is established, during that period, all the equipments which are involved, that time taken, and it will be released at the end of the call. Then unit of traffic. How the traffic will be indicated? What is the unit of traffic? So it is very important question. So the traffic intensity is the average number of calls simultaneously in progress. The traffic intensity is the average number of calls simultaneously in progress. The unit of traffic intensity is named as Erlong, which is indicated by capital E. Again, I'll repeat, the unit of traffic intensity is indicated as Erlongs, which is indicated as capital E. A traffic intensity of 1 erlongs is obtained in any specified period when the average number of calls simultaneously in progress during that period is unity, that is nothing but 1. The specific period is always 1 hour and taken as a busy hour. The traffic carried by a group of trunk is indicated by capital A is equal to C into H divided by T. Kindly remember this formula, it is very important for problem point of view. The traffic carried by a group of trunk is nothing but A is equal to C into H by T. A is nothing but traffic in Erlongs, that is capital E. C is nothing but average number of calls arrival during time T. Okay, next. H is nothing but average call holding time. Okay, C is nothing but average number of call arrival. A is nothing but traffic in Erlongs. H is average call holding time. If T is equal to H, if T is equal to H, this both will cancel and A is equal to C. That is, traffic in Erlongs is equal to number of call arrival during a period equal to mean duration of calls. Single truck cannot carry more than one call. That is, A is less than or equal to 1. Occupancy of the trunk. The traffic is a fraction of an erlong equal to the proportion of the time for which the trunk is busy, which A is equal to C into D, where C is number of call, T is the average holding time in hours, so which is indicated as A is equal to C into T erlongs. So occupancy of trunk is indicated as A is equal to C into T erlongs. So let us discuss an example. For this only I told to keep the calculator with you. so that we can solve a problem, or else I suggested you to install the app of scientific calculator, which are available in Play Stores and iOS stores also. On average, during a busy hour, a company makes 120 outgoing calls of average duration 2 minutes. It receives 200 incoming calls of average duration 3 minutes. Find the outgoing traffic, incoming traffic, and total traffic. So let us see what actually they are given on average during busy hour. On an average, during a busy hour, a company makes 120 outgoing calls. So number of outgoing calls is 120 and average duration is 2 minutes. Again, it receives 200 incoming calls. Number of incoming calls is 200 and average duration is 3 minutes. Now, therefore the holding time is 2 minutes and 3 minutes. Okay, to find the outgoing traffic. So first they ask you to find out the outgoing traffic. A outgoing, OG means outgoing, is equal to C into H by T. So it is given as uh, so H outgoing, they are given it as holding time is 2. So C is 120. So time is 60. So we have 120 outgoing calls, 2 divided by 60, T is 60 we know. So 0 0 cancel, 2 ones are 2 threes are, so 3 4 are 12, so it is 4 air longs. So outgoing traffic, that is AOG, is equal to 4 air longs. Okay, very simple one. Only thing is you need to find this, it will be easy. Okay, I will repeat. So we know the formula that traffic in Erlongs is given by A is equal to CH by T. Outgoing traffic is indicated by A of OG is equal to CH by T. So C is nothing but 120. How means it is 120 outgoing calls into 2. How 2 means they are telling it is average duration is 2, that is holding time is 2 minutes for outgoing calls, and divided by 60. How means the time is 60. So 0 0 cancel, 2 ones are 2 threes are 3 fours are, that is 4 logs. Okay. To find the incoming traffic, similarly A of IC, that is incoming traffic. So C is nothing but 200 because the the incoming calls are 200. 200 into 3, 3 why? Because 3 minutes is the holding time. So 3 divided by 60, 0 0 cancel, 3 ones are 3 twos are. So 2 tens are, so 10 air longs. So incoming traffic is 10 air longs. To find the total traffic, so total traffic is nothing but the sum of outgoing traffic and incoming traffic. It's simple, that is 4 plus 10, that is 14 air longs. So I hope you understand, all of you, this problem. It is very simple and it is very important. For exam point of view, they may ask for 6 to 7 marks. Next, example number 2. During a busy hour, on average, a customer with a single telephone line makes 3 calls and receives 3 calls. So during busy hour, that means 1 hour, on average, a customer with a single telephone line makes 3 calls and receives 3 calls. The average call duration is 2 minutes. The holding time is 2 minutes. What is the probability that the caller will find the line engaged? What is the probability of getting a caller the line engaged? That means we need to find the occupancy of line here. How to find the occupancy of line is 3 plus 3. That is how y is 3 plus 3 is 3 calls is making and is receiving 3 calls. So 3 plus 3 into 2. Y2 means it is the holding time is 2 divided by 60. 3 plus 3 is 6 into 2 by 60. Actually answer should be 0.2 not 0.1. Okay. So this is the probability of finding the line engaged. So next topic is congestion. What is the meaning of congestion? It is nothing but theoretically it is possible that half of the subscribers are in conversation with other half in the telephone exchange. It is uneconomical to provide an equipment for catering the requirement as the probability of occurrence of this situation is negligible small. In simple manner, congestion means if more number of calls occur for a period of time, then the congestion will occur. It is a situation at all the trunks in a group are busy in a simple manner. It is a situation at which all the trunks in a group are busy. No further call can be accepted. This state is known as congestion. That means no further calls can be possible. That means all the available trunks are busy. Then that situation is called as congestion. There are two types of systems in telecommunication network, that is queuing system and delaying system. Here, call during congestion wait in a sequence queue until an outgoing trunk becomes free, for instance, message switching. Last call system. Here, all attempts to make a call during congestions are unsuccessful. For instance, circuit switching. So, last call system. Here, all attempts to make call during the congestions are unsuccessful. For instance, circuit switching. So